Have you ever held a simple, unassuming sheet of paper and considered its cosmic potential? It seems impossibly fragile, doesn't it? A flimsy little rectangle, easily crumpled, easily torn. We use it for shopping lists, for doodles, for letters we might never send. What if I told you this everyday sheet could bridge the chasm to the moon? Sounds like science fiction. The universe hides truths in ordinary things. Let's do a thought experiment. In our minds, take that sheet. It's thin. Standard office paper is about 0.1 millimeters thick. That's a tenth of a millimeter. A human hair is about the same thickness. Stack 10 sheets, you get about 1 millimeter. Fold it in half. Thickness becomes 0.2 millimeters. Fold again, 4 layers, 0.4 millimeters. Fold a third time, 8 layers, 0.8 millimeters. Each fold doubles the entire stack. Doubling is exponential growth, the engine of our cosmic elevator. Our intuition is wired for linear thinking. 10 steps equals 10 times farther, but exponential is different, a runaway train. The first few folds seem trivial, almost laughable. Then the numbers don't just grow, they explode. This repeated doubling is one of the most powerful forces in the universe. It's the secret behind the growth of bacteria and the compounding interest in a savings account. And, as we'll see, it's our one-way ticket to the moon. Let's put some numbers to this magical doubling. We can express this growth using the language of mathematics, specifically with powers of 2. After one fold, the thickness is the original thickness multiplied by 2 to the power of 1. After 2 folds, it's the original thickness times 2 to the power of 2, which is 4. By the time you've managed, say, 7 folds, which is about the limit for a standard sheet of paper by hand, you've multiplied the original thickness by 2 to the power of 7, or 128 times. The paper is now about 1.28 centimeters thick, roughly the thickness of a notebook. It's getting stout, but it's hardly astronomical. But we are not constrained by the physical limits of paper. We are on a journey of the mind. Let's keep folding. At 10 folds, we're at 2 to the power of 10, which is 1,024. Our paper is now over 1,000 times its original thickness. At 0.1 millimeters per sheet, we've just surpassed 10 centimeters, about the width of your hand. We've gone from the thickness of a hair to the thickness of a thick sandwich in just a few imaginary folds. The growth is starting to become noticeable, but it's still on a human scale. We can hold this idea, and the imaginary paper, comfortably in our minds and our hands. Let's get more ambitious. What happens at 20 folds? The number we're looking for is 2 to the power of 20. That's 1,024 times 1,024. The result is over 1 million. To be precise, it's 1,048,576. Our stack of paper is now over 1 million times its original thickness. 1 million times 0.1 millimeters gives us over 100,000 millimeters, which translates to a stunning 104 meters. That's taller than the Statue of Liberty. Suddenly, our humble piece of paper, after just 20 folds, has become a skyscraper. We've left the realm of handheld objects and entered the world of architecture, all by continuing that simple act of doubling. Now, can you guess what happens at 30 folds? We multiply our stack by 2 another 10 times. We go from 2 to the power of 20 to 2 to the power of 30. That means we multiply our 104-meter stack by another 1,024. The result? Our paper tower would now be over 100 kilometers high. 100 kilometers. That's the Kármán line, the internationally recognized boundary where Earth's atmosphere ends and outer space begins. With just 30 folds, our piece of paper has become an astronaut. It has breached the final frontier and is floating in the vacuum of space, a testament to the relentless, explosive power of exponential growth. Let's take a moment to appreciate this incredible journey in scale. We started with something you can barely see, the 0.1 millimeter thickness of a sheet of paper. For the first few folds, the results were mundane. A millimeter, a centimeter. These are everyday measurements. But by the 17th fold, 2 to the power of 17, the paper would be over 13 meters tall, higher than a 3-story building. We're already past the point of anything we could call a stack and into the territory of a tower. The sequence is seducing us into a false sense of manageable growth before it truly takes off into the stratosphere and beyond. After crossing the 100-meter mark at 20 folds, our paper continues its ascent at a terrifying rate. By 25 folds, 2 to the power of 25, the thickness would be over 3,355 meters. That's taller than Mount Fuji in Japan and many of the peaks in the Rocky Mountains. Think about that. A mountain of paper created from a single sheet just by folding it 25 times. The base would still be the size of the original paper, creating an impossibly thin and tall needle piercing the clouds. It's a beautiful, absurd image that highlights how disconnected our linear intuition is from the reality of exponential math. Our journey doesn't stop at mountains or even the edge of space. We reach the Kármán line at 30 folds. Let's push to 40 folds. We've multiplied by 2 another 10 times, so we multiply our 100-kilometer space tower by 1,024. The thickness of our paper now exceeds 100,000 kilometers. The Earth's circumference is only about 40,000 kilometers. Our theoretical paper is now long enough to wrap around our planet's equator more than twice. We are dealing with distances that are astronomical. The moon is getting closer. Fold number 41. Our paper now measures over 200,000 kilometers. We have crossed the halfway point to the moon. The next fold, number 42, will double this again. 2 to the power of 42 is almost 4.4 trillion. Multiply by 0.1 millimeters and we get approximately 440,000 kilometers. And there it is. The average distance to the moon is 384,400 kilometers. With the 42nd fold, we have not only reached the moon, we have soared past it. It's a conclusion that feels like a magic trick, a sleight of hand performed with numbers instead of cards. Our intuition screams that it must be wrong, that something so thin could never span such an impossible gulf. But the math is clear, clean, and correct. The power of exponential growth is simply that staggering. It takes us from the microscopic to the macroscopic to the astronomical in a breathtakingly small number of steps. It reveals that the universe is governed by principles that can lead to outcomes far grander than our everyday experience would ever lead us to believe. So the next time you look up at the moon, hanging like a pearl in the night sky, remember the humble sheet of paper. Remember the power of doubling. This exercise is a reminder that even the smallest, most insignificant seeming things, when compounded, can achieve the impossible. It's a lesson written not just in our mathematics, but in the fabric of the cosmos itself. The journey from a single sheet to the lunar surface is a testament to the most powerful force in the universe, relentless, compounding growth. And with just one more fold, the 43rd, you would reach the moon and travel all the way back.